Okay, today we're going to look at the law of cosines. Now, we've already learned the law of sines. So when you have an oblique triangle that you cannot use the law of sines for, then you need to use the law of cosines. More specifically, when you have a side, 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 or a side angle, side triangle data from your triangle. So first we're going to look at the law of cosines, center form use when you have side angle, side. There's 3 formulas to memorize with this, so I like to memorize it in words first, and then I can apply that to whichever situation I have with the letters that I put in. So the law of cosines formula in words is you take the missing side, because you have 2 sides, so the one side that you do not know squared is equal to one of the sides you know squared plus the other side you know squared minus 2 times the product of the 2 sides you know times by the cosine of the one angle you know. And the one angle that's given should be opposite the side that you know, because if you had a side angle and a side opposite each other, you would use the law of sines instead. So in letters, in terms of a triangle ABC, that side A squared is equal to B squared plus C squared minus 2 times BC times cosine of A. If B is the side you do not know, it would be B squared is equal to A squared plus C squared minus 2 times AC cosine of BB. And if side C is the side you do not know, it's C squared is equal to A squared plus B squared minus 2 times AB cosine of angle C. So notice that the key is that if you don't know side A, you know angle A, cosine A. If you don't know side B, you know angle B. If you don't know side C, you know angle C. So that helps you figure out which combination to use. So let's try our first example. We're going to solve this triangle here where angle A is 25, B is 9, and C. So since I know angle A, side A is what I'm looking for. So A squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25 degrees. I like to just go ahead and get the A by itself, so I'm just take the square root of all this. So I only have to type it all in once into my calculator and type everything into my calculator at once. But if you wanted to simplify the right-hand side first, then take the square root of an answer, you can do that. But the key is you want to always save this in your calculator. Okay, so I'm going to type this into my calculator. Okay, so I'm going to calculate A in my calculator. So I'm going to do square root of 9 squared plus 12 squared minus 2 times 9 times 12 times by the cosine of 25. Now, make sure, don't forget to make sure that you are in degree mode. So I'm going to check my mode. So I go to my mode and I am in degrees. Degrees are highlighted so I can quit. And then push enter. And I get 5.41 is what I'm going to write down as my answer rounded to 2 decimal places. But I need to use this exact answer in my following. So what you're going to hit is this store button. And then this is side A. So I'm going to store this alpha A. And then push enter. So until I replace that, A will always equal this value. So that's how you store it in your calculator. And I got 5.41. On these, it's fine to round it to 2 decimal places is fine. But I'm going to store that actual answer in my calculator, so I don't want to use the rounded answer when I do my others. Now that I know a side and an angle opposite it, now that I know a side and the angle opposite it, I can switch to the law of sines, because the law of sines is much faster to use. So to find angle B, I'm going to use sine of B over 9 is equal to sine of 25 degrees over, and I'm going to use the entire answer A that's stored in my calculator. So I'm not going to use 5.41. I'm going to use the entire answer so I don't get a compounding rounding error. Okay, just like we've done in the last class, I'm going to solve this for B. So I'm going to multiply each side by 9. Then to find the angle measurement, you're going to take the inverse sine of this entire fraction. That's what I'm going to type into my calculator. Again, making sure I'm in degree mode. Okay, now we're looking at finding angle B. To find angle B, I'm going to do my inverse sine of the fraction, of the fraction. And the fraction needs to be 9 sine of 25 over my stored value for A. So we're going to do alpha A here. And then push enter. And there's where you get the 44.7. And I get that B is approximately 44.70 degrees. And now, only thing's left for it is to find angle C. Now, if I know two angles of a triangle, to find the last remaining angle, I just take 180 degrees minus my two known angles. And then finally, to find angle C, I'm going to take 180 degrees minus 25 degrees minus that 44.70. And I get 110.3 degrees. And I get that angle C is 110.30 degrees. Okay, it's your turn. I want you to look at this example, and I want you to start with finding side A. Okay, so we're going to use the law of cosines. So we got A squared is equal to 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of 80 degrees. Or A is equal to the square root of 16 squared plus 12 squared minus 2 times 16 times 12 times cosine of 80 degrees. Now I'm going to type that into my calculator. And I get that A is equal to 18.26. Again, store this in my calculator. Now I want you to find angle B. Okay, now I'm going to switch to the law of sines. And I have sine of B over 16 is equal to sine of 80 degrees over that stored A, which is that 18.2 ... Solve for B by first multiplying by 16 and then taking the inverse sine of that fraction. Now I'm going to type that into my calculator. I get B is equal to 59.66 degrees. Now that I know that B is equal to 59.66 degrees, I want you to find angle C. Okay, angle C is equal to 180 degrees minus the given angle of 80 minus the angle I found of 59.66. So angle C is 40.39 degrees. All right, now the second time that you'll use law of sines law of cosines is when you are given all three sides. So the alternate form will be used when you're given all three sides, side. Now, this form is just taking the original form and solving it for the cosine of A or whichever angle that you're looking for. So again, because these formulas change by which angle you're going to look for first, I like to remember by words. So cosine of the first angle I'm going to try to find is equal to known side 1 squared plus the known side 2 squared minus, now the side that you minus, so this is side minusing your known side 3, but this known side 3 has to be the side that's opposite the angle you're looking for. So if you're looking for angle A, this one that you're subtracting has to be little a. If you're looking for angle B, the one you're subtracting has to be little b. So the one you're subtracting squared has to be this opposite the side that the angle you're looking for. Now divided by 2 times known side 1 times known side 2. So those are the two sides that are not opposite the angle that you're looking for. Now, that divide sign should only be over the right-hand side of the equation. I kind of drew it a little too long there. So let's put that in symbols. I'm going to skip that first line for now so that and write it down here, the second one. So let's say if I'm looking for angle B, then I would have A squared plus C squared minus B squared divided by 2 times AC. If I was looking for angle C, let me just go clean that up. If I was looking for angle A, it would be B squared plus C squared minus A squared over 2 times BC. And if I'm looking for angle C, that's going to be A squared plus B squared minus C squared all over 2 times AB. All right, so we're going to find the 3 missing angles of this triangle. So again, notice that law of cosines, the side that you subtract squared is also the side is opposite the angle that you're needing to find. Okay. So for example 2, we're going to find all 3 angles that's missing from this triangle. So we're going to solve this triangle. Let's start by finding angle B. So if I want to find angle B, I'm going to have cosine of B is equal to 8 squared. And so since I'm finding the plus 14 squared minus the 19 squared, because the little b, and that's going to divide by 2 times 8 times 14. And then again, to get b by itself, I'm going to do the inverse cosine of this fraction. Now we're going to go to our calculator and type this in. Okay, now I'm going to show you how to do your calculator for this finding angle B with the law of cosines. So again, that's going to be the angle whose cosine is our fraction, 8 squared plus 14 squared minus 19 squared divided by 2 times 8 times 14. And I get 116.80. Now again, remember I want to store this angle B. So this is going to store alpha B. So now that's stored in B, and that'll always be my B until I have it some other time. So I'm going to write my answer of 116.80. And we'll get B is approximately 116.80 degrees. Stored this exact answer, full decimals, into your calculator in B, so we can use it later when we prevent a rounding error. Now that I know angle B, I can find our next angle, let's say angle A, and I can switch to the law of cosines because now I know a side and an angle opposite. So if I want to solve for angle A, I'm going to have sine of A over 8 equals sine of this 116.80 over 19. Solve this for A. I get that A is equal to the inverse sine of 80 over sine of 116.8 ... over 19. Okay, you are next asked to find angle A. So angle A is equal to the inverse sine of the fraction, 8 sine of my angle B, so alpha B, divided by 19. And you get that angle A is 22.08. So I'm going to store that in alpha A. We get A is approximately 22.8 degrees. Now, finally, to find our angle C, we're going to take 180 degrees minus the 2 angles we found. And so to find my angle measurement for C, it's 180 minus alpha A minus alpha B, and I get 41.12 degrees. We get C is approximately 41.12 degrees. Okay, now it's your turn. So looking at this situation, given 3 sides of the triangle, I want you to find the missing angles. Let's start by first find angle A. To find angle A, I'm going to use the alternate form of the law of cosine. So that's going to be cosine of A is equal to 8 squared plus 12 squared minus 6 squared divided by 2 times 8 times 12. Punching that into my calculator, I want to do the inverse cosine of 8 squared plus 12 squared minus 6 squared divided by 2 times 8 times 12. To get that angle A is approximately 26.38 degrees, storing this value in my calculator as A. Now I want you to find angle B. To find angle B, we're going to switch to the law of sines, and we're going to have sine of B over 8 is equal to sine of that 26.38 ... over side A of 6. Multiply each side by 8. And then take the inverse sine of each side to get angle B. Punching that into my calculator, I get that angle B is approximately 36.34 degrees. Last but not least, we're going to find angle C. To find angle C, we take 180 minus the 2 angles that we just found. And we find that angle C is approximately 117.28 degrees. And so that is how you can use the law of cosines. The last thing we're going to learn in this video is Heron's angle area formula. Now, Heron's area formula is used when you have the situation of side, side, side. So when you're given all 3 sides of a triangle, this is where you're going to use Heron's formula, area formula, to solve oblique triangles, known when you know all 3 sides of an oblique triangle. Heron's area formula is equal to, area is equal to the square root of S times S minus side A times S minus side B times S minus side C. Well, S, that's a new symbol, where S is defined by A plus B plus C, so the sum of all sides divided by 2. All right, let's apply this formula. We're going to find the area of a triangle having sides lengths 43, 53, and 72. So first find S. So S is equal to 43 plus 53 plus 72, all divided by 2. I get that S is approximately, or X is actually equal to 84. So area is going to be equal to 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. So I want to do the easy subtractions here. And I get that area is equal to the square root of 84 times 41 times 31 times. Okay, so we already figured out that S is equal to 84. So to do this in our calculator, find the area, I'm going to do the square root of 84 times 84 minus, well, sorry. We already figured out that we already figured out that S is 84. The square root of 84 times 41 times 31 times 12. And we get the area of 1,131.89 square meters. 12. And then just using my calculator, punching that all in, I get area is approximately 1,131.89 square meters. And this is how you find the area of an oblique triangle if you know the 3 sides of the triangle. Your turn. Find the area of this given triangle ABC. Okay, first I want you to find S. Okay, S is equal to the sum of the 3 sides, so that's 5 plus 9 plus 8 divided by 2. And that gives us S is equal to 11. Now find your area. Area is equal to the square root of 11 times 11 minus 5 times 11 minus 9 times 11 minus 8. Area is equal to 11 times 6 times 2 times 3. The square root of that. And then area is equal to approximately 19.90. Now we know how to find the law of solve any oblique triangle, either using law of sines, law of cosines, or the combination of both.